The lecture starts from here. After the machine is imported, what we need to do? We need to check the settings. I need to make sure that I have host only adapter which has the IP address of 10.10.0.1 series. Why? I'll answer that when my machine is running. This is required 10.10.0.1 series, and then you need to verify in the settings under networking that you have the adapter properly configured. Like first adapter should be NAT, that is network address translation, and second adapter should be host only adapter, but that adapter third should be selected here. That was wrong selection by default. So I selected adapter number 3 now, and now I can start my machine. In fact, because of RAM constraint, so I want to reduce the RAM of this machine. 4.5 GB, that is too much of RAM for this machine. 3 GB is sufficient for me if I give 3 GB to this machine, and 2 processes are good enough for my requirement. So 2 processors and 3 GB RAM, this is how you can change in the virtual machine. And now I start the machine. Once my machine starts, I'll brief you in the meanwhile. What happens is the default installation from the default repository was available till Oracle Linux 7. Starting with Oracle Linux 8, there are known issues and is not fully supported on Oracle Linux 8. But I plan to install it on Oracle Linux 8. Remember, if you are using Oracle Linux 7 or CentOS 7 or RHEL 7, then it is quite straightforward. It is yum install docker. That's it. Whereas if you are using Oracle Linux 8, then you have to do some workarounds, which we are doing. We are going to do that. That workaround is you first need to set up the repository for Docker container engine, docker-ce. Once the Docker repository is set, it will start conflicting with your Oracle Linux 7 repository for some packages. So in order to resolve that problem, we need to install one package from CentOS 7 repository. Now the package which will be installed from CentOS 7 repository, that will be old release. So the version mismatch will happen. Though that is mandatory for our Docker requirement, therefore we will use one option during the installation. That option is called nobest. So I'm logging in as root user. Oracle is the password of this machine. Open the terminal by right clicking and open terminal. So the terminal will open, and here we need to set up the repository for docker-ce, and then we need to install or CentOS 7 repository, a package from CentOS 7, and then we need to install Docker. Config manager, add repo. This repository is available at this URL. Like if I open this, I can show you. Right click on it, open link. This will open the link in the Firefox browser. This docker-ce.repo is available from Docker website, and this will be, it will offer you to download it or save it. So you can manually download the file docker-ce.repo, and then you put it inside the directory. The directory name is etc yum.repos.d. The same job is done by this docker dnf config manager. If I check that ls-l /etc/yum.repos.d, you will find this file there, docker-repo.ce. The purpose of the repository is to make the database of dependencies and packages available related to Docker in your installation tree. So the repository is by definition is nothing but the database of all the packages and the corresponding dependencies, including the specific version required for that package. Complete dependency tree will be built in the database. In fact, this database is in the form of XML file and compressed file. Now I'm going to install the old version CentOS 7. From the CentOS 7, if you look at this repository, this package container.io, this package is required, and if you install the latest version, that will conflict with this package available in this repository. Therefore, I'm using the old version from CentOS 7 repository, and Oracle Linux offer the package which is incompatible. That is the workaround. So we install containerd from CentOS 7 repository. Is not available in Oracle Linux 8. If you install it from Oracle Linux 8, that will become incompatible with the Docker from the Docker repository. So it is a kind of lock situation, deadlock. You try to resolve Docker, it will conflict here. If you try to resolve this, it will conflict there. So to outcome from the Docker, this deadlock situation, we are installing the old version, and then because this old version is good enough for our requirement, and then we install docker-ce, and using the option, we don't want any best version of this containerd. I'm going to install docker-ce with additional parameter, and the parameter is hyphen hyphen nobest. That hyphen hyphen nobest will help me install the package without bothering about the dependency conflict of this containerd, because this is old version from CentOS 7 repository. So that is a workaround which I'm going to do now. Let's wait till it is installed. Installation is complete, and now install docker-ce. No best. This will install docker-ce now, and now we need to add this, modify this user modify docker user, we are modifying, and the group we are modifying, we are creating a group docker for him. So docker is installed. Now you can start docker systemctl start docker. This is first time start, so it will take little time, because it will create a network by default. There is a network that will be created here, and then enable it so that it is started automatically, and you check the status whether it is running or not. So docker is running. Q to quit out of it. Why it took time? Because when you run it for the first time, it create a bridge also, like the docker 0. This is created by this installer. This was not there before the installation, before the start of the service. Now our docker is running. What next? Simple docker and press enter key and wait for it to display what all commands options we can use with docker. And that's what the docker command take all these management commands, or general commands, or the options. So we need to provide options, what do we want to use, then management commands, then general commands. So a lot of commands are there which we use in docker. To start with, we should use to check the details, what is happening, what is the environment we have. For that you can use docker info. Docker info gives you information about your system. Start from here, like client, there's nothing you can see here as of now. Server, right now you see zero container, zero running, zero pause, nothing, no images. This is containers, right? Then we have storage driver, overlay 2 driver is being used right now. Blocking file system, backing file system is NFS. So you can see a lot of other things. Swarm is the cluster which will we activate tomorrow. We'll configure Swarm, and this value will change from inactive to active, and the status and the role of this node in the Swarm cluster. Right now it is inactive. So that's the statistics about the current Docker. And to run a container based on an image, first you need to check what all images we have. So that is Docker images. Right now there is no image. So how can we search and pull images? Let's try something. Docker search, and let me use some search command. Let's say busybox. Busybox is a image which offers a lot of Unix utilities for your training, for your practice. and a good starting point, a base image, very powerful image, very good image to use Linux commands or Linux utility. We use it. Another similar image is Alpine. This can also be used. So let's pull both these images first. So to pull these images, we use the command docker pull Alpine. You can think of any application and search on Google, and like whatever application coming to your mind, you want to use that a Docker image for that application, just go and search Google. So I'm searching, I'm downloading BusyBox image. This is called pull, Docker pull. We are pulling the image from the Docker Hub. So by default, it is pulling from Docker IO library. And this is the latest image. This is the tag name. So these images, now if I try and check the images, you will see these two images. If you use -q, that will show me quick list. -a show me all images. So generally this command makes sense when I want to delete all images, because I can pass the entire command as a group to another command. That will create a very good shortcut for me to delete all images, for example, if I need to do that. So I'm going to use the same thing again, docker. Now there's another way to do it, docker run, and this is another image I'm using, docker run hello world. This is interesting. I know that there is no image with the name hello world in my case, but I'm trying to run it. Docker is intelligent enough. If you try docker run and image is not available locally, so by default it will go and search Docker repository for the image, and it will pull that image and run that, and that's what I'm going to do. So and you see the message, enable to find image locally. So it is pulling from the library and installing it and running it. Yes, so downloaded image is downloaded. So docker run is essentially docker pull followed by docker run. Choice is yours. Now you want to first pull and then run, or you want to directly run. One is the same thing. So this message hello from docker, this is actually a message which is being displayed here. So now if I try, we have three images. So these are the three images I have. And what about containers? How can we check the container? Because now I'm running a container based on the image. So how can we check that? PS command, but it's not showing any container, but we created it. So where is our container gone? A container depends on how you are running. It is running in detached mode, it is continuously running, or the container is nothing but displaying some message and quit. We may have this kind of containers. The lifestyle, a lifespan of the container may be as small as run it, display something, and quit, exit. So how to check that yes, we have a container which is not running but which was there? So we can use -a switch. So now you see it was a container which was actually created with this container ID, the name hello world, command was /hello, and about a minute ago this container was done. Right now it is exited. That means it was quite simple container which was not doing anything apart from displaying a message. That's it. So it run and it exited. What if I want to run a container based on MySQL server? How can I do that? So for that I can use first, let me search what all MySQL I have. So I'll use docker search MySQL. It will show me the MySQL images. Now what are the columns? Let's understand these also. This is MySQL image, description of the image, stars means popularity, it is official. Official does not mean that it is provided by the developers of MySQL. No. Official word here refer to that it is provided by Docker. Docker is managing this. If you want to search official MySQL repository, means from Oracle company, from MySQL account. For that you need to type MySQL server. That will show you the account name. You see here When you search for this MySQL/MySQL server, this image is managed by Oracle. This is not find Oracle. So you see official, there is nothing in official, which means it's not a Docker image. This image is MySQL image from the MySQL account, because just before image, if you see slash and before that some name, that means that is the account holder. Like the same image is provided by this company also, like this paged tech. They also provide this image. It's possible because it's open source. Anybody can create image. You can also create. You can also host your images. So these are companies who have created these images. Some are automatic, some are manual. If it is automatically built from the source code, then you will find automatic OK. So let me pull this image now. Docker pull. This will pull the image. Docker pull MySQL server. Oh no, I have to provide the account name MySQL/MySQL server, and it is optional. It is better to provide the version also 8.0. That is fully qualified name of the image. Account name slash image name colon tag name. This image name basically may have multiple images, so it's better we can call them as a repository also. MySQL server repository, and from that I want to pull the image with the tag name 80. Think of it like a lot of Linux versions are available, but which one you want? So what should we call it as, a repository or image? That makes sense. So it will pull MySQL server version 8 from MySQL account, and this is what it's doing right now. That's how you pull the images, guys. How can we create a volume storage? That can also be done using a simple command like docker volume create, and let's say my volume. That's how you can simply do that. My volume is created. If you see docker volume ls, that will show you the volume which you have created. If you want to inspect this volume, that is persistent storage I was talking about, ls command, oh sorry, docker volume inspect, that will give you inspect, sorry, docker volume inspect my volume. That will give you details about your volume, where it is actually created. It is available here, and it is with this directory. So it is located here. This is external, and this can be attached and used by any container. So we created persistent storage, we created the containers, we pulled images, we understood how to run images, and let's run MySQL server. So docker run -n or hyphen name MySQL1. This is my name I want to give, and the image name is okay, let me put it in detached mode -d, and the image is MySQL/MySQL -server :8.0, the image which I have downloaded. So this will run the container in detached mode. Now this is something, this container is something which is not a exit, I mean display something and exit. It has to be properly running, and that you can verify with the docker command, docker ps. That will show the running container, and see, you can see that container ID, and it is running 21 seconds ago, and it is running up. So you can, it is available. In fact, it is open port number 3306 to interact with and connect with this, and the name is MySQL1, which we specified with --name. That was a brief installation and getting started with Docker. Let's go through the lecture now. This is lecture 2, session 2, Docker installation. You have already seen the installation. Let's quickly go through this also now. Installing Docker on Linux, understanding installation of Docker on Windows, some Docker commands. Installing Docker. Docker installation packages are available in official Linux repository. Here is a minor correction, and the correction is if you are talking about CentOS 7 or Oracle Linux 7. If you are using Oracle Linux 8, then you have a workaround. Probably it's not supported in Oracle Linux 8. So yum install docker engine. After installation is completed, you need to start the docker daemon. We have done that. Verify it is running with status command. Docker desktop on Windows. Docker desktop for Windows is community version of Windows, Docker for Windows. So system requirement for Windows is Hyper-V backend and Windows containers. For Windows 10 64-bit, it is supported on Pro, Enterprise or Education build number 17134 or higher. Hyper-V and container Windows switcher must be enabled. WSL2 web backend, Windows 10 64-bit, Home, Pro, Enterprise or Education, version 1903, build number 18362 or higher is supported. Enable WSL2 feature on Windows. If you are Windows, it is for you. Common hardware requirements are 64-bit processor with second level address translation, that is SLAT. 4 GB RAM, BIOS level virtualization must be enabled. Installation steps are quite straightforward. Download the installer and run it. So if you don't have already downloaded the installer, that is docker desktop installer.exe file, download it. It is available on Docker Hub, that is hub.docker.com. Run this installer. When prompted, ensure the enable Hyper-V Windows feature. This is checkbox is enabled, or install require Windows component like for WSL2 option is selected on the configuration page. Follow the installation instructions on the installation wizard to authorize the installer and proceed with the install. When the installer is successful, close it. If your admin account is different to your user account, then you must add the user to Docker user group. Run this computer management as an administrator and navigate to local users and groups from that groups and then Docker users. Right click to add the users to the group, log out and log back in to for the changes to take effect. Using the Docker command. Docker command consists of using this command consists of passing it a chain of options and subcommands followed by arguments. So Docker, then options, then command, and then arguments, as you have seen. To view all available subcommands, you simply type docker. You have seen that, and I demonstrated it. System information, you know now. I demonstrated that is docker info. So docker info will give you complete details about your current status. Working with Docker containers. Docker containers are run from Docker images. So you need to have it locally. You need to create it or pull it from the Docker Hub. And even if you run without the image, it will try and search the image with that name. So by default, it pulls these images from Docker Hub. Anybody can build and host their Docker images on Docker Hub. To check whether you can access and download images from Docker Hub, try running that hello world example. So docker run hello world, you have seen this, and we could download and we could run this. So docker run hello world, so that you will see this message docker hello from Docker, that will confirm that everything is fine. Running a Docker container. Containers can be interactive. As an example, let's run a container using the latest image of MySQL server. The combination of -i and -t, that is interactive terminal, this switches gives you interactive shell access into the container. So this is what I demonstrated. I use the same command docker run name MySQL1 in detached mode, and the image name was MySQL/MySQL server, tag name is 8, and this is we have seen that. Verify the running container. Initialization of the container will begin, and the container appears in the list of running containers when you try docker ps command. You have seen this also. -d option used in the docker run command will make the container run in the background. The full form of this -d is actually detached mode, though you can think of it as a daemon, because anything running in the background is called a daemon. Use this command to monitor the output from the container, that is docker logs mysql1, that will display the messages, logs of your container from the container means. And you see in the logs itself, you can see the password, temporary password generated for this MySQL server. Interesting point here is how can we fetch this password? I'm using here my docker logs MySQL1, and then what am I doing here? This is interesting. This is 2 greater than %1. Let me explain this. 2 greater than symbol %1. So these 2 and 1 we call them as file descriptors. There are 3 file descriptors, 0, 1 and 2. 0 is for standard input, 1 is for standard output, 2 is for standard error, and all these can be redirected. Now the answer should be clear. Now this symbol should be clear. As I said, you can redirect standard input, you can redirect standard output, you can redirect standard error. Now you see very clearly here I am redirecting the standard error, 2 greater than symbol. If you don't use 2, by default it will be taken as 1. So I'm using 2 greater than means I'm redirecting the error, and this %1 is concatenation of the input stream 1, and 1 is what? Standard output. So I'm appending the error messages with standard output both. Once both these outputs are generated, that is errors and log, because by default you can separate the two. Error can go to different stream and messages can go to different stream. Error can go to file, messages can be displayed. Messages can go to file, errors can be displayed. Both can be sent to a file. Errors and messages, I mean errors and output, both can be redirected and clubbed together. Choice is yours. You can separate them or keep them. Here I'm keeping both them together, and then I'm piping that output to another command. That command is grep command. So the both output, error and output, both are clubbed together, and then I'm grepping this text from that grep generated root password. So in other words, I'm interested in fetching only this line from my whole bunch of output, and this will give me the generated root password, and I can use this password to log in now. So use docker execute -it command to start MySQL client inside the container, and then run the command MySQL command to log into the MySQL server. So this is the command to log into MySQL server, but because you are going to run it inside a container, therefore you have to use this command docker execute interactive terminal container name and the command you want to execute inside the container. So docker execute -it MySQL1 MySQL username and password. So you can expect this output. So docker execute, it will ask you the password. You grabbed the password in the previous screen, you paste that password, and first thing which you do after logging in is you change the password. So this is the password is changed here. To have shell access to your MySQL server container, use docker exec-it command to start a bash shell inside the container. So you can simply do the same thing again, but this time bash. Docker execute interactive terminal MySQL1 bash. This will give shell prompt. Stopping a container is quite simple. To stop a container, you can use docker stop MySQL1. Notice that when the main process of a container is stopped, the docker container stopped automatically. To start MySQL server again, you can use start, docker start MySQL1. To stop and start again, you can use restart, docker restart MySQL1. To delete the MySQL container, you need to first stop it, and once you have stopped it, you can use the docker rm command. So docker stop and then docker rm. Rm will remove the container, not the image. Listing the containers, to view all containers active and inactive, you can use -a switch. I demonstrated that docker ps-a. To view the latest container you created, you can use -l switch, docker ps-l. Stopping and running a container or active container is as simple as typing docker stop container id. These are cleanup commands. List all the containers docker ps-a, stop all the running containers. So same command docker ps-a-q, and I pass this command to stop. So docker stop and all containers, so all the containers will be stopped. Delete all the containers because docker ps-a-q will display all the containers in short form, only the container IDs will be given. Therefore, if you use docker rm and the container ID of one by one all the containers, this command will remove all the containers. Remember, you need to stop the container and then you can delete. If you delete the container without stopping the container, it will create the container again. So this is sequence number 1, this is sequence number 2. Similarly, docker images will display all the images. To remove all the images, you use docker rmi, -f. This way you can remove the images. Again, if the image is used by a container, you can remove it. So sequence has to be clear. First stop the container, then remove the container, and then remove the images. Creating and managing volumes. Unlike bind mount, you can create and manage volumes outside the scope of any container. I demonstrated this also. Docker volume create, my volume, listing volume, you've seen that, docker volume ls, and then inspecting volume, you have seen docker volume inspect, and then after that I have not demonstrated this, I'm sure you can do it, docker volume remove my volume. That's all for this session. Thank you very much, guys.